So if that's the right mental model, a question we could ask ourselves is, should AI ship straight to prod? What could possibly go wrong? As you might imagine, quite a lot can go wrong. Vibe coding is a great example of this classic trade-off in software between better, cheaper, and faster, right? And the usual intuition is you can pick two of the three, but not all three. So I want you to think about where you would put vibe coding on this triangle. When I first heard about it, I think I would put it sort of way over here. It's much faster, it's much cheaper, but also much, much worse, or much, much riskier at least. And given that it's so much cheaper and so much faster, I think it's worth asking what we can do to mitigate those risks. And is there a way to improve this balance? And is there a way to maybe get better, cheaper, and faster? And that's what I'm here to talk about today. But first, what the hell is vibe coding? The term was coined by Andrej Karpathy back in February. In his definition, it's anytime AI is writing the code, but for him, he didn't even need to read it. Just sort of have it try stuff and tell it seems to work and then ship it. Like the napkin coding example this morning, right? Now he was talking about side projects and prototypes, not critical production code. But it's since caught on his way to describe anytime the AI is the primary author of your code and you're maybe just reading and reviewing it and looking at the end result. So for this talk, I'm going to use that more expansive definition because I think that's how we're going to be using it in our day-to-day actual work. So why is this at all relevant to our day-to-day work on production software? Because beneath all the hype, I think it's delivering huge value as measured in actual revenue dollars and time to market. So a quarter of the current YC batch used AI to write almost all of their code. And those aren't just a few cool demos. Back when Airbnb did YC, they stood out by growing revenue 10% week over week, far exceeding the rest of their batch. This current batch is averaging 10% week over week across the whole batch. Like, that's crazy, right? And a big part of that is these new AI coding tools. They allow small teams to move a lot more quickly. So where's that value created? There's a couple examples up here. Generally, it's the work that's obvious, right? It's what needs to be obvious, what needs to be done, because it's just applying some common pattern to your specific use case. And to oversimplify, it's sort of mostly a matter of just typing it out, right? These are the things you can do today with Amazon Q Developer and other AI coding tools. And they're getting dramatically better every month. And it makes sense that that's what AI is good at, right? They've been trained on a million examples of React apps and CRUD APIs. So if vibe coding is great for AI luminaries like Andrej and AI native startups, and we can use it for all these useful things, shouldn't we all be vibe coding? What could possibly go wrong? Well, there's a bunch of obvious risks, and these are all taken from real world examples that have either been shared on social media or I've encountered myself. I won't go through them all in detail, but they're all cases of the AI being intelligent but not wise. So even when the AI does what you ask it to, it often only does what you ask it to, and not all the other things that you would implicitly know to do if you were the one writing the code yourself. But notice, with the exception of prompt injection, none of these are new risks, right? They're all risks that any dev could introduce, are especially common with young junior devs. And I want you to think about how we control for these risks today, because we'll come back to that. But it's the less obvious risks that I think we want to pay more attention to. These are the kinds of things that more experienced engineers have learned the hard way, right? The risks that remain, even if the change the AI made is perfectly correct in some narrow sense. So for example, the LLM might decide to use a literal SQL query instead of using your ORM. And maybe it avoids SQL injection and it correctly includes the tenant ID and the where clause. But what happens if some later refactor adds some additional tenant protection via your ORM? Now suddenly that code is dangerously incorrect. Or what if you're processing health data and you ask the AI to just make it faster for you, right? Maybe the LLM decides it's smart to store that EPHI unencrypted in Elastic Cache. Like, hey, job done, it's faster. Again, none of these are totally new risks, right? Does it really matter if customer data is exposed because an AI made some mistake or because a developer did? So think about how we control for these risks today. Then zooming out further, there are some big long-term risks. And I think these are mostly genuinely new risks. If we control for many of the more or less obvious risks by careful PR reviews and documentation, how does that work when the velocity of PRs is increasing really dramatically, right? And that's what we want to happen. That's sort of where the value comes from for much of these tools. And if AI can do the work of junior developers, where are we going to get the next generation of senior developers? How do we account for tech debt when nobody who created that code is still on the team, or nobody has ownership of that code? And something that matters a lot to me personally, I think in code, right? I often don't understand a problem until I've sat down and really tried to implement a solution. Even as CTO, I always insisted on personally reviewing like the most critical parts of the code, because otherwise I can't really understand it. And so, I think we should be asking ourselves, what happens if nobody is looking at these critical parts of the code? It sounds scary. So can we or should we just opt out of vibe coding? As an industry, we've learned a lot about how groups of fallible humans can deliver robust software, relatively robust software. Why throw all that out the window just because a bunch of startups are saying, hey, this is going to work great? Or maybe you're thinking, well, this is fine for small startups with small customers and small teams, but it never work at my big company. We've got giant enterprise customers and lots of legacy software. So there's no way we'd try to implement that here. We're never going to let some product manager, vibe code something directly into prod, right? Right? If that's what you're hoping, I have some bad news. First, developers are already using AI coding tools, probably all at your companies, if not you yourselves. And most of them love it, especially for these really tedious tasks, right? Like writing tests or updating dependencies. And the latest coding agents are getting better than ever. So now you can just open a GitHub issue, assign it to an AI agent. It'll open a PR, you review that PR and provide comments and feedback, just like you would a human team member. And most companies are actively encouraging use of AI coding tools. So the pressure to fully adopt vibe coding is only growing. And every established company is watching AI native startups steal market share with less than 5% of their headcount and better margins. And every CEO is watching the incredible pace of innovation coming from AI leaders and thinking not just, how can my company take advantage of these AI tools, but also, how can my company move as fast as these AI native companies? So we're in this really weird spot where everyone can see how dangerous this is with today's tech, but everyone can also see how enormously valuable AI coding agents are going to be. And everyone is afraid of being left behind, which isn't, for companies, isn't just a matter of like looking old fashioned, right? It's an existential risk of losing their customers to faster moving competitors and going out of business. So I think very rationally, most leaders are looking at the rate of improvement and thinking, look, by the time my org actually implements this stuff, it's going to be good enough that most of these risks have gone away and I don't have to worry about it. We can operate safely. But my personal bet, and the whole reason I wanted to give this talk, is that I don't think that's going to happen. I think AI coding tools are not ever going to get good enough that we can use them for the most critical software problems, even if we get to AGI levels of intelligence. So that might seem like a weird claim. Why don't I think even AGI could correctly and safely make changes we want in our critical software systems? Well, for one, intelligent humans can't do this reliably, right? I don't know why we'd expect artificial intelligence to be dramatically better. You might be thinking, well, AI is actually much better than humans at a whole bunch of things already, right? Why not building reliable software? Because I don't think it's a question of intelligence. I think it's a question of culture, or maybe cultural technology. It's all the stuff that we've invented to make sure that a bunch of highly fallible humans operating in different contexts, communicating through very lossy channels, can still build pretty reliable software. And that's the good news, in my mind. As an industry, we've been building software for something like half a century now. Over that time, we built and refined cultural technology in the form of best practices, standard operating procedures, laws, and regulations. And we've invented a bunch of software technology to make it easier to apply that cultural technology. Things like pull requests, CI/CD pipelines, infrastructure as code, all of which has helped us build and operate more or less reliable software systems despite our individual fallibility. And almost all of that can be directly applied to AI and vibe coding. Really, the only thing that's changed is that the risk of not applying these lessons are much greater, but also the rewards of applying them are much greater. So let's get really specific. What are the most important lessons and best practices that we can apply to vibe coding, and how can we apply them practically today? So first, there's a ton we can learn from security, right? The whole industry is built on the assumption that bad things are going to happen, so we need to be prepared for them. I think a really useful mental model for AI-generated code is to ask, what if an attacker was influencing the AI's output? We've seen some real examples of this with prompt injection, but I would argue it's useful to think of AI as always potentially hostile because you can never fully trust its output. That's why defense in depth and principle of least privilege are so important. You can and should make it so that even if the AI-generated code does something wrong, it simply can't do the worst things and the most dangerous things, even if it were trying to. So for example, if you have a service that recommends products based on a customer's shopping history, it shouldn't have write access to anything, right? And it shouldn't have read access to the user's name or address. It's been best practice to have security tools scan your code and you're running services for vulnerabilities or suspicious behavior. But many companies still consider this kind of a luxury more than a necessity. But deploying AI-generated code without them is kind of like driving your car without seatbelts or airbags. Like, you might be fine, but if something goes wrong, you risk turning a minor incident into something really catastrophic. And another thing I found really helpful is to use your agent instructions file to explicitly tell it to follow specific security best practices, like accounting for the OWASP top 10. All major coding agents include support for some kind of instructions file. So Amazon Q calls these rules files, project rules. You can just add markdown file with rules for avoiding things like cross-site scripting or request forgery, for example. And sticking with the vibe coding theme, you can have an LLM write your instructions file. It won't be perfect, but it's better than nothing. Of course, the ideal is have your security team write it, or at least have your security team vet it, and also standardize it across your whole org. So change management has always been the first place where we add safety and compliance steps to control for risks and make risk of making changes. So it's a very natural place to focus improvements. First, you can use AI agents in your PR process to both require an explicit risk score and to suggest what that score might be based on the code that's changed. That risk score can then inform extra steps that the agent might take in the PR process, like pulling in more reviewers or suggesting that reviewers focus on specific high-risk areas. You can use AI to flag migrations and infrastructure changes for extra testing and staging environment before deployment. So it's especially important when your AI agent might be making those changes without anyone realizing it. You can use AI to document user stories it's trying to address, and then use the full list of your user stories to have a browser agent do end-to-end testing for each of those scenarios. These are all things that we know we sort of should be doing today, but likely aren't because the ROI isn't quite there. Good engineering teams mostly know to do these things informally where appropriate, and maybe that's been good enough. But if your team starts shipping vibe-coded changes without these in place, suddenly the risks are much, much higher. And by using AI, the cost of implementing these controls is now lower than ever. And you can do it in a way that actually speeds your team up and not slows them down. From release engineering, we've learned the value of testing in production with feature flags, canaries, and fault injection. But in a vibe coding world where our production systems will be changing faster than ever, I think it's more important that the correctness of those and the correctness of those changes is more uncertain than ever. These goes from nice to haves to must haves. And again, these are now easier than ever to implement, Most agent frameworks now support browser usage, so it's now very cost effective to test every single change to ensure it didn't break your most important user stories. And since it's cheap and scalable now, why wouldn't you test not just your happy paths, but your unhappy paths? So make sure your user still has a good user experience if a service is down entirely or returning errors or otherwise degraded. So you don't have to go all in on event sourcing or CQRS to get some benefits from event processing patterns. A really easy place to start is stick critical requests into something like SQS. Make sure you've got a item potency token on that, of course, to prevent double processing. And then if there's an error, it'll retry automatically after the visibility timeout expires. And if the retries fail, it'll end up in your dead letter queue. And you can then go fix the bug, maybe vibe code the fix. And at worst, you've delayed the response. You haven't dropped that response entirely or dropped that request entirely. And that's been a recommended pattern for a long time now. But if we expect a higher rate of AI-induced bugs, I think it's more valuable than ever to put that into place. And once you've got that async pattern in place, you can now do a lot more things like blue-green deploys for your data pipelines. So gradually shift events from the blue queue to the green queue. And if you see a higher error rate, roll back. Or imagine you've got a bug that affects 1% of requests. You vibe coded a fix, but you want to make sure it doesn't break the other 99%. So you can use SNS to fan out to both the blue and green queues and compare the results carefully to make sure the only difference you see is the difference you expect to see. And because you're using your item potency token, you actually can do full processing in both queues. So as long as your new green queue drops those 99% case if an error is detected, they're still being processed correctly out of your blue queue. People have been doing this kind of thing for really high-risk changes manually for a long time now. But in a vibe coding world, why not do that for every single change as part of your normal deploy pipeline? For little extra processing costs, you get a dramatically reduced risk of customer-facing regressions. So I said before, the risks of AI coding aren't entirely new risks. They're just amplified versions of existing risks. And I think that's especially true for observability. At large companies, it's unfortunately common to find yourself on call for a service you're not very familiar with. Maybe everyone who knew that code has left the company. I've been there. It's terrifying. So what helps? Good docs, good system diagrams, good metrics and alerts, remediation playbooks. And that's the dream, right? That's what we've always hoped for. But we can't even keep our docs up to date. I never have. I don't know if any of you ever have done that successfully. And that's with today's rate of change. How on earth are we going to do that with the rate of change is dramatically faster as enabled by AI? So this is honestly one of the things I'm most excited about. I think there's enormous potential to use AI to keep your docs up to date with these changes to answer questions like why, based not just on the current state of the code, but on the change history of the code, and to connect all of that with live metrics-driven visualizations. I think we'll need a new generation of ops products to fully realize that potential, but something you can do yourself today is make your docs, system diagrams, metrics dashboards, part of your project source code, then make sure your PR process includes updating those. And you can stick all that in your agent instructions file so that every time a change is made, it updates the docs along with that PR and updates your diagrams if necessary, if upstream dependencies or downstream dependencies are changed. So one last set of lessons I think we should keep top of mind is the value of small and well-defined abstractions. Those have always been the ideal, but I think it's more important than ever if you have AI writing and reading your code. LLMs perform much better when the whole code base fits into the context window. And it's much harder to break some feature unrelated to the change you're trying to make if that feature isn't even implemented in the code base that you're changing. Exhaustive test coverage always felt like an ideal, but with AI-generated tests, it's possible to get much closer to full coverage. And while I don't want to weigh in on the microservice versus monolith debate, I do think it's worth at least rethinking that trade-off in light of AI coding agents. So just do all of software right and we'll be okay. What could be simpler, right? This is going to be a chaotic and dangerous time, transition in our industry. It's going to be dangerous for our customers. And And I think it's going to happen faster than any of us are really well prepared for. But just like industrial transitions of the past, I think there's a real chance that this brings with it the opportunity to genuinely make things better as well. So let's revisit this better, faster, cheaper trade-off. Hopefully I would convince you that, like, if you do vibe coding without being prepared, you'll end up somewhere way over here, much better and faster, but also much, much worse. But if we spend just a fraction of the time and money that we've saved with vibe coding on just applying some of these lessons, I think we can make this a much more reasonable trade-off. And I think there's an even better possibility here, which is if we apply enough of these lessons, we can not just pick a better point, we can actually reset this trade-off, get better, cheaper, and faster than what's possible today. And that's the whole point of any new technology, right? Once something is matured and deployed, every new generation of technology resets what this trade-off looks like. We don't yet know what mature vibe coding is going to look like, but I think if it's really successful, it'll let us operate at a higher level of abstraction. When the solution is obvious and the code needs to be correct and secure, but not particularly innovative or clever, let an AI do it. And let's be honest, most of the code we write is in that category, right? For me, over 90% of the code I've written in my career, I'm sure it falls into that obvious category, kind of just needs to be typed out. And yet almost all the value that I think I created was in that last 10% that was not obvious. So if we put the right protections in place to do vibe coding safely, it'll allow us to spend much more of our time doing the work that we really love and the work that's really valuable. So we can mitigate the risks for companies doing vibe coding, but if AI is doing the work of junior engineers, how are we going to get today's junior engineers to become tomorrow's senior engineers? Now, this is talked about a lot, but in my experience, years of doing the obvious coding work is not at all what makes a junior engineer into a great senior engineer. Great senior engineers are made by learning the hard way what can go wrong through firsthand experience for all the things outside of code, right? The code's the easy part. And that's exactly what I think junior engineers will continue to learn if they're vibe coding. They'll still learn what good code looks like by reading and reviewing it. If anything, reading code, I think, does more to teach you what good code looks like and the downsides of bad code than writing it. But more importantly, they'll still be on the front lines in production to fix issues when they come up. They'll see what makes customers and colleagues happy or angry. And they'll learn how their choices today make the things they want to do tomorrow easier or harder. Granted, for a given product, I think we'll likely need fewer engineers, fewer junior engineers, but we'll also probably need fewer senior engineers and probably fewer of everyone, of every role. But if we apply it right, AI will let us do more of the innovative work that we love and less of the mindless work that we hate. And it'll let us do that work in smaller, more nimble organizations. And maybe most importantly, it'll let us experiment more cheaply to more quickly explore the whole space of possibilities. So if we can control our enthusiasm and avoid throwing out everything we've learned in the past 50 years, we can maybe have all that and safer and more reliable world for ourselves and our customers. So to recap, vibe coding is coming. It can be done safely, applying all the lessons you already know. And it'll be so valuable that the companies that do this right will dominate those that don't. Thank you. Do you have any questions?